Now we're going to look at permutation of things when they are distinct, that is they are different, and they are replaced, something like this. So here I happen to have 5 objects and I had to pick one of it and place it over here, but we can see that it's been replaced. So for the next box I'll have all the 5 as an option, right? For any consecutive boxes I'll have all the 5 options. So basically the answer over here is 5 into 5 into 5. So 5 to the power of 3, right? So selecting 3 objects out of 5 wherein the objects are distinct and they are being replaced, the answer is 5 to the power of 3. So what does the formula look like? So if we happen to have n objects and we have to pick r number of times, right? So the answer would be permutation over here is n to the power of r. So we don't have a similar representation over here. We just write permutation is equal to n to the power of r. So it's an easy concept, simple formula. So we'll see a few examples. Selecting 2 objects out of 3. So first thing is I'm going to use tree diagram. First I'll be showing without replacement. I have 3 objects. I have to pick 2 out of the 3, but I'm not going to replace. That is, if I pick red, I don't have an option of red in the next time when I'm going to pick. So basically I have blue and yellow, not yellow, green. So here if I happen to pick blue, I don't have an option of blue over here. So here I end up with 6 different possibilities. But with replacement, let's see what happens. So even though I happen to pick red, I have an option of picking red again. So here I have the answer to be 9. So how will we get 9 out of the formula? So first thing first, here what is n? N is the number of things and r is the number of times we're going to pick something up. So basically we have the permutation to be equal to n to the power of r, which is 3 to the power of 2, which is nothing but 9, right? So pause and try the next question. It's quite simple. So what is the answer? Yeah, it's quite simple actually. So we're looking at n to be equal to 4, while n to be equal to 6 actually. And r is 4, right? So the permutation that is possible over here is n to the power of r, which is 6 to the power of 4, which is, well, 6 to the power of 4. I'm not going to solve that. So that is your answer, right? So I don't have the animation for that, obviously. It's not easy. Selecting 4 out of 6. Yeah. Right, guys. Again, this is a case wherein the objects are distinct. They are different. And as and when it gets selected, anyone gets selected, there is a replacement for that, right? So you can pause and have a look and do write it.